Good morning, students. Welcome to Physics Plus. Today we are going to study about the expression for the maximum speed when the body is in under the circular motion. So we already discussed about when the body is in the leveled boat, then what is its maximum? The velocity. Now let us pass on to a body. I'm considering a car here, is under the water, the circular motion. So here, whenever the car or a body is under the circular motion, so the road itself is what here? The bend. So it means that it's a bending. At one side, it will bend. Then what is its the maximum the speed of the car or the maximum speed of a body? Now this is the circular part when a car is just moving. So what is the radius of the circular path? The radius of the circular path, let us call it as an r. And mass of the body is considered as what here? M. And the acceleration due to gravity is considered as what? G. Then the same thing I am considering here. Okay. So this is the bank of the road. So it is banked what here? Rise it to the theta. A theta is an angle. Then it's the total weight of this body depends on the mass and also the gravitational force. Then it is actually the downwards. This is the mass into the gravitational force. Then what is the reaction force? The normal reaction force is always like this. Okay, it's a normal. Here is this is the surface. This one is the normal. Just it's mentioned as what? N. This N is divided into the two components. One is an horizontal component, another one is the vertical component. Let us say n cos theta, and here we have a n sin theta. So this particular force is acting the downwards. Let us call it as an F. So here also we can able to divide into the two components, F sin theta, and here is an F cos theta. So let us say from the diagram, okay, from the diagram, okay, from the figure, we have n cos theta. The n cos theta is equal to n cos theta is equal to F sin theta plus what is this? M into G. F sin theta plus what is that? Mg. So therefore Mg plus F sin theta. Call this equation as what here? First equation. Now there is a force is acting. So always this force is acting at the center of the water, the circular path. That force is termed as a what here? Centripetal force. So how much of the centripetal force is acting on it? So that is n sin theta here, n sin theta plus what is it? F cos theta is equal to what here? The centripetal force, that is mv square divided by what is that? R. Okay. The centripetal force is given by mv square divided by r is the radius, that is equal to n sin theta plus of what is that? F cos theta. So let us consider this particular equation as can consider two. The first equation and also another one is the second equation. Now you already know that the force, so F of S, okay, F of what is that? Yes, is less than or equal to, less than or what here? Equal to the static friction we can call. Okay, the static friction of the body is less than or equal to, you can able to say the mu of S into normal force. Mu of S is nothing but a coefficient of a static friction into M. So let us substitute this for the first equation. Let us consider the first equation here. So what happens here? N cos theta is equal to M into G plus F of sine theta. Therefore, what happens here? N cos theta is equal to M into G plus F is nothing but what here? The mu of S into N sine theta. So mg is equal to, what is mg? Mg is equal to n cos theta. So this becomes this side is minus of mu of S into N sine theta. What is common here? The common is n. N is the common. So therefore mg is equal to n into cos theta minus of mu of S sine theta. So therefore what is n here? So therefore n is equal to mg divided by what is this? Cos theta minus of what is that? Mu of S sine theta. Now we already identified what is the normal reacting force on the body. So the normal reacting force, that is N, is equal to mg divided by cos theta minus of mu of S sine theta. Substitute this equation. Substitute that equation in equation what? The 2. Okay, substitute in equation what? 2. What is the equation 2 here? mv square. So let us say mv square divided by r is equal to n. N is nothing but this one. So therefore mg divided by cos theta minus of mu of S sine theta into what is the area? Sine theta plus f is nothing but what here? Mu of S into n. So n we have already written. So what is left out here? Sine theta plus of what is that? Mu of S cos theta. Okay, mu of S cos theta. So therefore I can able to write like this: sine theta plus of what you will get? Mu of S cos theta. Mu of S cos. Now let us consider m1 m get cancelled. So what we will get? V square divided by r is equal to, we put here sine theta plus of what is that? Mu of S cos theta divided by cos theta minus of mu of S sine theta into r is here, another one is g is here. So just put it as r into g. Divide this particular equation by cos theta. Okay, just transfer here. So therefore I can able to consider. So here, so v square. Okay, v square is equal, or I have taken here. So therefore, divide this equation by cos. Sin theta by cos theta, what happens here? Tan theta. So therefore v square is equal to tan theta plus of cos theta by what here? Cos theta. Then what happens here? 1. So it will remain as what here? Mu of S divided by cos theta is equal to 1 minus of sin theta by cos theta is equal to tan theta. So therefore mu of S tan theta into what you will get? R into G. Now let us consider here the mu of S is equal to 0. Let us consider it as a 0. 0 means here the coefficient of what is static friction is 0. Whenever it is becomes a 0, so what happens? Okay, what happens to this? So this becomes 0, therefore v square is equal to tan theta divided by, this becomes 0. 1 minus of this is entire thing is becomes 0, so therefore divided by what is that? 1. So what is left out here? R into what is that? G. So therefore, what is the final equation? V is equal to the root of, okay, R into G tan theta. So this is the maximum speed. Okay, let us say it is a maximum, V maximum. So it means that the velocity possessed by the body whenever it is under the body, circular motion is equal to V is equal to R into G tan theta. Okay. So under the what here? Vector rho. This is an expression for what? So when a car or a body is moving under the what here? A circular path and a vector. So thank you very much for watching this video. Thank you.